All right. Good afternoon, everyone. Hi. Thanks for coming at the end of a conference, or the day is finishing to a technical presentation. Very courageous of you. Thank you. Hi, I'm Daniel. I come from Paris in France. I look like this on the internet. I look like this in real life. I work for a company called VMware in the Tanzu Spring org. Ta-da! It's not a clothing company. We do IT product. In the Tanzu application platform, I work on the SSO component to protect your app with single sign-on. I also work in the Spring Security ecosystem, contribute to the Spring Security open source stuff, Spring Security itself, Spring Authorization Server. And I also teach at university, CS 101, a little bit of Python, a little bit of web and stuff like that. You can find me online. Reach out. It's always a pleasure to answer email, direct messages on Twitter, on Mastodon, on wherever. And then I'll be happy to engage about Spring Security or anything else that you want to talk about. So before we get started and we dive deep, who here uses Spring Boot? Keep your hands up if you use Spring Security as well, right? And keep your hands up if you think Spring Security is an easy product to use and that you really understand what you're doing. So we have one hand, two hands, two courageous people, and I guess that's why you're here, right? To learn a little bit more and demystify all of this. So disclaimer before we start. I'm going to be talking a bit fast. That's not because I had too much coffee, but because I have too much content. So I'm not going to go into all the details of Spring Security. Actually, the goal is not to do you a cool demo of 45 minutes. The goal is to give you the basics, the basic building blocks that Spring Security uses so that you can understand what it does and that when you need to customize it, you can customize it on your own and not go to Stack Overflow, copy paste some stuff that you don't understand, and then it doesn't work, and then it's very frustrating. So we're not doing that. We will be focusing for this part on the authentication side of things, so logging in the identity of the person who logged in. There's an entire side of Spring Security which is about authorization, so permissions. Am I allowed to see page X or page Y? We're not going to be talking about this today, but you should be able to derive the knowledge from what I show you. Also, we're going to be using servlet applications, so regular Spring MVC, not showing reactive. Reactive has slightly different primitives, but it's the same concepts. So if you follow this, you should be able to apply most of the things in Spring Security Reactive. And please keep your questions for the end of the presentation because I think we won't have time for questions. So let's do that in the hallway track. All right. So I always like to start my presentations with a demo. It's a bit short, so I can't build all the things in front of you. So instead, we're going to start from an existing application that has Spring Security in it, and then we will be expanding on top of that. If the demo gods are with us, because my Wi-Fi is not working and I'm tethered to my phone, so we'll see. So we have a basic Spring Boot application, and it has a controller with two pages, the slash page, which is public, anyone can see it, and then the slash private page, which is private, you need to be authenticated to actually see it. This is configured through Spring Security, so something that you should be able to see in the docs. You used to configure Spring Security by extends web security configure adapter. That doesn't exist anymore in Spring Security 6. So if you followed the docs online, you've seen that you should provide a bean of type security filter chain, and it kind of looks like what you used to do. And what do we do for this application? First, we say how we want to protect the pages. And so basically here, we're going to say the public page, anyone can access it. Same for the favicon, the CSS, the error page. Anything else, you must be authenticated to actually see the page, right? So this is one of the important patterns that you will find in Spring Security is secure by default. This is what you should be doing, because if tomorrow I add a slash foo page, by default, it will be secured, and then it's a conscious decision to open it. And then I explain how the user can log in, and then they can log in two ways, form login, so username and password, or OAuth 2, so doing single sign-on with Google. I've configured this with Google. And for the demo, I hard-coded a user with a name user and a password, which is perfect. This is what you should be using in production. And we'll be logging in with this. All right. So Spring Security 6, provide a security filter chains, use authorized HTTP requests, not authorized requests. That's the new way. And the application looks like, let's go to localhost 8080. Oh, I have to start it, of course. Here we go. So right, there's a public page and it has a button. And when I try to go to private page, or if I try and navigate to the private page here, I have to log in because the page is secure, so I can log in with username and password, and it tells me, hello, user. I can log out. Actually, I'll do it in a private window, localhost 8080. So if I want to go, I can log in with Google with my slow phone, vmware.com, and this should perform SSO on my behalf with my company systems, and then I should come back at the end to my application having logged in with Google. If my phone follows the redirect, shows me the images, and hello, Desgarnier at vmware.com. Right. So very simple application, nothing crazy. You should have, if you use Spring Security, you've done stuff like that in your own applications. So now the question is, how does Spring Security do that? How does it do that for us? Oh, demo, you can grab it online. I'll give you the link at the end. There are all the steps that are used to build the demo and then that we're going to present during the presentation. So how does Spring Security achieve this protection, and how does it build this for you so you can build your own stuff? It uses three important building blocks: the filter, the authentication provider, and then at the end we'll see the configurer so you can explore a little bit how this is actually configured within Spring Security. The most important building block is the filter. It's a thing, it's a class, it's an implementation of an interface that takes a request object, which represents the HTTP request. It takes the response object and it can interact with it to make security decision. This is hosted in a filter chain, right? So a filter chain is just a list of filter, if you want, in order that will process the request. Maybe they will decide to do nothing. Maybe they will block the request. Maybe they will augment the request with more information, and then they will yield to the next filter. And at the very bottom of the chain, there's the thing that produces the content. So your servlet container, Tomcat, for example, has a filter chain. And at the bottom, there's a servlet that produces HTML, JSON, whatever you want it to produce. In the Spring world, there's a sub-chain that is called the security filter chain, and it contains all the security filters. And at the bottom of this chain, you'll find your methods in your @controller, right? So your get mappings, post mappings, and so on. And so each filter takes the request, decides to do something with it, and then passes on to the next filter or blocks the request. As you noticed, there's an arrow that goes both ways. So after the controller is done generating a request, all the filters will continue executing. So how does that work? Well, a filter takes the request object, the response object, but also the filter chain in which it is contained. First, it makes a security decision. For example, ooh, this request doesn't look legit. You're trying to inject JavaScript. I'm going to block this. If the request is legit, it's going to call back to the filter and say filter chain, to the filter chain and say do filter. And the filter chain will be calling back the second filter. And so at the end, after all the filters have been called, after the content has been produced, we can do a little bit of cleanup after in the method. So another way of representing this in object-oriented parlance, the filter chain has a list of filters and it has a current position for a given request. And so when you call do filter on it, it selects the first filter, calls do filter on that filter, and then the filter itself makes the security decision, calls back to the chain, which increases the position, reaches the second filter, and so on. So that's why the stack trace kind of looks like this. The filter chain calls into filter 1, which calls back into the filter chain, we call filter 2, and so on. And so that's why you have these weird stack traces sometimes, and you have a hard time debugging. Why do I have a exception translation filter and a session management filter and an anonymous authentication filter? That's because they're stacked on top of each other, right? So that means if filter 2 throws an exception, potentially you can catch it in filter 1 and decides to do something with it, right? Okay, so that's all there is to know about filters. So how do we use them? Well, we can do a simple filter. Since this is Zurich, we're going to make a filter that we call verboten filter, right? And that will decide to say no to certain type of request. No, this is forbidden. So it must implement the filter interface, the servlet, this one. But if you do this, there's a few questions about life cycles, right? You have a bunch of methods that you can implement. So I'm going to give you the shortcut instead. You want to extend once per request filter. Most of the time, that's what you want to do, unless you're doing very specific stuff. Most of the filters in Spring Security are implemented on top of once per request filter, and it has one method you must implement, which is called doFilter internal, not doFilter, but you get the drift, right? It takes a request, a response, and a filter chain. And this, we're going to start by just logging. So let's maybe think, estas verboten, right? And so that filter, I have created it. Now I need to put it in the filter chain. And to put it in the filter chain, you go to your security config and you say add filter before. New verboten filter, right? And I need to put it before a filter, before something else. The good place to put your filters is usually before the authorization filter. The authorization filter is the filter that actually realizes this. Says, oh, you're not authenticated, you should go, you're not allowed to go further. But usually you can put it before any filter you know. The order sometimes matter, but most of the time not. What you have to remember, if you use authorize HTTP request, you put it before the authorization filter, right? So if I run this, run the application again, and we go to my terminal here, and we say HTTP AT-AT, right? So I do an HTTP call, and I see my log. There's a problem with this, though. If I go to my public page, I go here, I get a blank page. So if you've been following this, if we could go back to the verboten filter, what's the problem here? The chain, yes, we're not calling into the chain, right? We have to call doFilter request response. So in here, run this again, and we have a normal behavior again, right? If I refresh, I see a bunch of estas verboten logs, right? So now let's make a security decision on this. And so we're going to look at the request, and we're going to check the headers, and we say if you have an X verboten, X because it's a custom header that I give meaning to, and if the value is equals to, is it var, right? If it's true, if it's actually forbidden, then we're going to reject the request. Otherwise, we filter, right? So if it's forbidden, we reject the request by saying the response is forbidden, status forbidden, right? And then we're going to write to the response, right? And we're going to say, right, a bunch of those. Das ist verboten. We write this in the response, and then we make sure that we return, that we don't call the rest, right? We cut the filters, we cut the filter chain. We say stop, don't even go to the control, don't try to log in, just stop here. And since I am a funny person, I add emojis. So you have to think about character encoding. Fun. Right? Okay. So run this again. Normal page should still be the same, right? If I go here and I try and get the public page, I get the public page. But now if I add a header that's called X verboten var, then das ist verboten. I don't, is that too small maybe? Let's a bit bigger like this. But if I put another value, say falsch, then I get the normal page again, right? Makes sense? So how is that actually used within Spring Security? So how does Spring Security build filters to actually do this kind of behavior? So we're going to inspect an existing filter, the CSRF filter, which provides cross-site request forgery, CSRF protection. Who knows what cross-site request forgery is? Anyone? Oh, good, 50, 60%. For those who are not sure, let's explain quite quickly. The idea is I am a user. I go to my banking website, and I log in, and I get a session cookie that represent the fact that I'm logged in, and now I can interact with the bank and send money, and then I can, change my account details and so on. That cookie is saved in my browser. Now, if I go to a malicious website, like these are totallyrealnews.com, and they have a big button that says, to win an iPhone, click here. If I click there, actually, it's not just a button. It has a hidden form in it, and it says transfer money to account X with the amount. And it targets not the malicious website, but the bank website. And if my browser is not smart enough, now with the protection, it's harder to pull this off, but it will send the request to the bank website with my legit session cookie. And so I will be sending an order to the bank to do some wires. And that's not cool, because I want to win an iPhone. I don't want to give someone money. So how do we protect against this? Well, we implement CSRF protection. So what do we do? When we go to the banking website generates a token. So here in this example, the value is YYY. It stores it on a server in its database in my session, in my server-side session. So only the bank can know this value. When the bank produces a form, it injects a hidden field in the form and says, your CSRF token is YYY. So when I post, I send whatever the form is supposed to be sending. And then I also send my CSRF token YYY. The bank server receives that token, says YYY, in your session you have YYY, they match. This form was produced by us. This is legit, let the transaction through. If someone crafted a form to do this and hosted it somewhere, or even hosted it on the bank website by injecting the HTML, they don't know what's in my session. They don't have access to this. They hard-coded it in HTML form. So either they put a wrong value in it, XXX, or they put no value, but the server of the bank receives either no CSRF token or a wrong value, says, no, this is not valid. I'm stopping the request. So how is this implemented? So Spring Security does the CSRF filter. And so let's look at this real filter, CSRF filter. So it has a do filter internal, just like we implemented with the verboten filter. And so what does this do? First, it creates a CSRF token and it saves it so that it can be injected into forms, right? So even if I don't need to protect, it generates one for me in a lazy, smart way so that it's not resource intensive, but it creates a token. Then it asks, does this endpoint require CSRF protection? So is it a post request to a sensitive endpoint? If it doesn't require CSRF protection, it's just going to carry on and let the rest of the filter chain do its thing. If it does require CSRF protection, well, it's going to grab the CSRF token from the session, it's going to grab the CSRF token from the request, and then it's going to compare them like this. If they are not equals, access denied exception. You're not allowed to see this page. We throw some events, we do a whole dance to alert someone, and we return. We don't call into the rest. We don't process, so our controller never sees that request coming in. If they are equals, that's a legit request, filter chain, do filter, right? So nothing crazy. That's actually easy to follow. However, that means you kind of have to understand what the security protocol or what the security measures that are implemented actually are to be able to extend those, right? Because if you don't, it's kind of difficult to parse what is this CSRF repository and so on. So filters. Spring Security has a lot of filter for us, and if I want to discover what is actually loaded into my filter chain, what will be executed, there are many ways of doing this. One is just looking at the logs, and when the application starts here, the default security filter chain gives me a log, and it says your request will be secured with those filters, so the disable encode URL filter, the web async manager integration filter, and so on, all the way to the verboten filter and the authorization filter that we mentioned in the beginning. So of course you can go and put a breakpoint in the default security filter chain here, right? You'll get your list of filters. You could explore with this. If you want a more dynamic view and you want to see the filters being called one after the other, the trick that you want to do, and this is where I don't show you my credentials, logging level, you're going to say everything under Spring Framework.security. Give me trace level logs. So give me as precise logs as you can. Run the app again. And we're going to make our request. That's verboten, right? Like this. So if I go back to the logs and I unwrap this, it tells me, Spring Security gives me a lot of debug and trace level, right? Debug and trace. And it says I am securing the slash endpoint because I made a call to slash. And I'm calling first the disable URL encode filter, which is number 1 over 17 in the chain, and so on, so on, so on, all the way to invoking verboten filter, 16 over 17, and nothing else happens. So probably the request was stopped here, right? So you can learn a little bit, okay, this went on, and it gives you much more information. Remove the traces because that's very noisy. So TLDR for the filters. So what did we do, and what does Spring Security do? Create a filter. It reads the request. Sometimes it writes through a response. Sometimes it does nothing. And then we put it in the filter chain. It must come before authorization filter, which is the thing that actually says, "Ooh, this private endpoint is private," or this public, anyone can go. Cool? Sound good so far? Nothing too crazy? All right, but that explains how we protect some endpoints by cutting the request, but it doesn't really explain how do we perform login? How do we do authentication? Well, this is done with an authentication interface. So authentication is kind of the domain language of Spring Security. It represents the user or the entity that is logged in. And it serves two purposes. One, which is authentication. So the knowing things about the identity. This is Daniel. He was born on April 22nd. He lives in Paris. And it also helps perform authorization. Daniel has the role admin, so he can see the page/admin, but he does not have the role, user, so he cannot see the page profile, for example. In this talk, we focus on the authentication part, but the rest is easy to piece out from what we're going to be talking about here. So this authentication interface has a bunch of things inside, a bunch of objects or methods. It has a principal. The principal in the authentication is the identity of the user, right? My username, birth date, so on. It has authorities, which represent my roles, my scopes, my permissions. So obviously, we're going to be caring about the principal in this presentation. It also has a method that tells you whether this person is authenticated or not. Most of the time, if you have said, this page must be authenticated, is authenticated will be true, and you don't have to worry about it as a consumer of that authentication object. It has details in it. So, for example, the IP that the request came from, and so on. And it has a credentials object, which is usually null. So when you get your authentication in a controller, so let's see the controller here. Here in the private page, we get an authentication object. That authentication object, if you call get credentials on it, there is an extremely high chance that the credentials are null. Because you, as an application developer, or I, as an application developer, I don't need to know the password. Right? The password is a security concern. It came before the user logged in. Now that they are logged in, I should not be able to see their password. Okay? And this is an interface. So you can create your own subclasses. And in fact, you should create your own subclasses if you have custom needs. What I often see is that people create username password authentication token, which is a subclass. But it's not the only subclass of an authentication, right? There is a username password authentication token, but if the entity that is logging in doesn't have a password, for example, you should not be using username password authentication token. You're going to be shoving things that are not right in this container. Actually, so for example, for Auth2, I have a bunch of Auth2 related authentication objects. For testing, there's a testing authentication token. So you should be creating your own subclasses that fit your need if you're doing custom login, right? And so what does Spring Security do with this authentication object? It puts it in the infamous security context, which is a global object for the thread that is executing the request. It's a it's a thread local variable. It's cleaned up after, so you don't really have to worry about. What this actually means is that in the controller, I got my authentication injected, but I could get it from the security context folder, get context, get authentication. This is exactly the same. This is actually what Spring does to give you this authentication object, right? If you can, you should prefer injection, but if you're like 5 methods deep in your service stack, maybe here's a good time to pull this one out to get the authentication without having to pass it down, 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 down. Okay? All right. So remember our filter? Why we make a security decision, we call to the rest of the filter chain, and we do a cleanup. Actually, a real filter that performs authentication kind of looks like this instead. So first, we decide if we should do something with the request or if we just let it through. Second, we make the security decision, for example, performing an authentication. Third, we call to the rest. And four, there's no for, we don't do cleanup because cleanup is usually a framework level stuff that you don't have to think about. So let's make something out of it. We have a very nice application. It has a public page and a private page, incredible. We can log in with username and password with auth2, but now I have a new requirement that a robot account needs to log in every night to check the private page. And so we could hack around the form login, and so have a parsers that reads the page to grab the CSRF token, that makes a request, that gets a session. That's complicated, so let's use Spring Security, and let's use headers here in this case to perform authentication. So how do we do this? We're going to create a new filter again. And this is the robot authentication filter. Again, it extends once per request filter. That makes sense. Implement the methods again. So we said 1, decide. 2, authenticate. 3, call next if you want. So filter chain, do filter, request, response, and then no cleanup because we're fine. Okay? And so to authenticate our robot, again, we're going to be reading a header. We get the X robot password header, and we compare that to the value beep boop. Right? So the valid value for that robot password header is beep boop. So if they're not equals, if I try and log in with a beep beep password, I should get rejected. So we already have an example of rejected requests. So let's do something similar. All right. We'll rewrite the message after, and I'm going to also set the content type so that it shows nicely in my browser with my lovely emojis that are so important. All right. Charset is UTF-8, right? So that's how we reject. But then if the passwords are the same, what do we do? Well, we create a new authentication object. We're going to call it robot authentication token. This is usually how they're called in Spring Security. Create that class. Amazing. So it must implement authentication. If we do this, we have a bunch of methods that we have to implement. Most of them we don't care about. So you can use a higher level abstraction, which is the abstract authentication token, which has a bunch of things already implemented for you. And we need a constructor. Amazing. So our constructor doesn't take anything, and it produces an authentication. And this entity that logs in has a role, and the role is robot. Fine. Credentials, I say they would be null most of the time, so let's keep them null, right? We don't care about passwords here. And then the principal, it's just going to be the name of the entity. Here it's Mrs. Robot. Beep boop. And we want that one to be authenticated. So we could call superset authenticated to true here in the constructor. That's one way of doing it. I like following another of the patterns of Spring Security that came after this class and this interface, which is immutability. I'm going to say this class is always authenticated, return true. And I'm going to signal, oops, not a constructor. I'm going to signal that if you want to change my authentication status, you're not allowed to do this. Throw new runtime exception. Please don't touch my auth runtime exception, I said. Right? Status. Scream. Right. So nobody should be actually using that. And so we have our robot authentication filter. We create an auth. So same in Spring Security, right? We try and follow this pattern of immutability. So we could get context and set the auth. We recommend not doing that. What you do instead is you create an empty context. That's the new context that's going to be used for the request. And then in that new context, you set the authentication to the auth. And then in the security context holder, you set the context to the new context. Unfortunately, you can't get around this mutating this thread local global variable. Okay, and so a nice error message. Let's put this and let's put a robot. You are not Mrs. Robot! Exclamation mark. Cool. So no backslash. So run this again. All right, so we have our normal filter here. So now if I try and call the private page and I pass it an xrobot password and I say this is beep boop, right? Then I have to register that filter, of course. Security config. So again, we add the filter, new robot authentication filter here, right? Register just like the other one, the verboten filter. Okay, call again. This time here, I get the private page and it says, hello, Mrs. Robot. It works. If I try and pass beep beep, then it yells at me because I am not Mrs. Robot and I'm trying to hack it. So this is fine and dandy, but there is a problem again. If I run this page here, it yells at me for not being Mrs. Robot, right? Because obviously my browser doesn't send the xrobot password header. It doesn't know how to do this, or like I don't have to hack this. And this is where the idea of deciding that you want to do something or not comes in. Here, we only want to apply this authentication action when there is an actual xrobot password header. So in here, we are going to block the headers, maybe the names, and we put this in a list. And we say if it contains xrobot password. So if it contains xrobot password, or if it doesn't contain, it means I don't need to do authentication. I just proceed as is, and I will do maybe a forum login authentication instead. I trust the filter chain to do the right thing here, request response. I don't need to produce an authentication. I just skip, right? So run this again. Now our page should be back, and the beep beep should still yell at me because I sent it a wrong header. Beep boop, still happy with me. Okay, so that's a classic implementation of an authentication filter. And if you look at authentication filters within Spring Security, they're fairly similar to this. All right, so recap, some filters do perform an authentication. Some just block requests based on, on the payload. Some do perform an authentication. They read the request to make a nice authentication object. They set it in the security context and they pass to the rest of the filter chain. Or if the credentials are invalid, they block the request and say, no, you should not proceed further. You are not Mrs. Robot. When the credentials are beep beep. Sound good? All right. 59. That's good. All right. So we have filters, we have authentications, and we perform authentication within a filter. But think about a new use case. So our website is so good. It has 3 ways of authenticating. It has 2 pages, very, very, very crazy. And now we have hired an admin, and his name is Daniel. He's very nice, very friendly, lovely hair, right? But he has a very, very bad memory, and he cannot remember his username and password. That's not possible. So we're going to create a new rule, and we say, if you try and log in with Daniel, the password doesn't really matter. Right? We're just going to log you in. And so if we were to do this, we could think that the way to do it is to create a filter and then, read the username from the request, read the password from the body, and then make a decision. But then where do I put this filter? Do I put it before the normal username authentication filter? Do I put it after? There's a lot of questions, and it's a lot of, I'm going to store the thing in the security context, which the other filter already does. So Spring Security has another layer of abstraction here for you, which is the authentication provider. An authentication provider is a thing that makes those authentication objects a little bit more powerful, right? I remember when I told you it's always authenticated and the credentials are always null. I lied. Sometimes the credentials are not null, and sometimes they are not authenticated. Actually, an authentication happens in an authentication manager. So an authentication object can be either a bag of credentials, so my username and my password, or the successful result of an authentication that checked those credentials. And this happens in Authentication Manager. So basically, with a username and password, usually how this happens, you create a username password authentication token, or Spring Security does that for you. It puts the username and a password inside. Then it uses authentication providers in this authentication manager to check the credentials. If they are valid, it produces a new username authentication, username password authentication token. It doesn't have just the username and the password. The password dropped because it doesn't need to keep the password. It has more details about me. It has my date of birth and so on. And it has the roles that I have, right? In my database, it says Daniel's an admin. If the credentials are invalid, this throws an authentication exception. It says, that's not correct, go away. So I mentioned authentication providers. This is because the implementation of Authentication Manager you should care about is the provider manager, which allows you to register a list of authentication providers that take an authentication object, produce another authentication object when the authentication is successful. They can produce null and say, well, I don't really know what to do with those credentials, so maybe there's another provider further down that can do something with it. Or they can throw an authentication exception, like the password is incorrect, you should not try with another provider, or this account is locked. Even if the password is correct, do not log this person in. Okay? And so we can do that for Daniel. So instead of doing a filter here, our dear Daniel admin is going to have a Daniel authentication provider. And this implements authentication provider then. Authentication provider. So it has two method supports, which tells you which type of bag of credentials it supports. So here in our case, it's username password authentication token. So if I see a robot authentication come in, I'm not going to try and mess with it, only when someone tries to do username password login. So if it's assignable, then I'm going to do something with it. And then the action of logging in is we grab the name. If it's equals to Daniel, right? So if it's equals to Daniel, we do something special. Let's use object equals here. So we create a new user with username Daniel, and then with password, I'm going to be able to do it with, password, that's why. It doesn't really matter, it's going to be deleted anyway. And then authorities, or maybe roles. Daniel is both a user and an admin. We build that. That makes a nice user object, and we return a new username password authentication token, which uses this user. Here it's credentials. I don't care about credentials. They'll be deleted anyway. And then the authorities, the roles of the user, we can grab them from that user object. If the username that comes in is not Daniel, I return null. And so the legit thing that checks the password will be called by the provider manager after. It's going to say, well, I got null here, so I'm going to check if anyone else wants to verify this username password authentication token. So, and we have to register it, of course. So again, in the security config, we can add an authentication provider, a new Daniel authentication provider like this. Run again. Beautiful. And here, that means if I run this and I say Daniel and I don't look at my password, right? And it says, hello, Daniel, right? But if I try and do that with user, and I type something that's wrong, I still get the normal behavior, right? So I didn't have to touch any filter to do this. And I get a bunch of free stuff from actually implementing an authentication provider rather than a filter. One is that here the credentials, if we look at this, like if we were to look at the request that comes out, the filter will check the body of the request, and it will check the form values in it. However, there are other ways of producing a username password authentication filter. For example, we could use HTTP basic to log in. Right? HTTP basic is we send a header with a username, the password, base64 encoded, And so if I do this, right, this HTTP basic, I add HTTP basic, so it's a new way of discovering credentials in the request. The Daniel filter that I created is still valid, right? So if I say the auth here is Daniel and then any password, it still logs me in as Daniel, right? But if I try and log in as user with foobar instead of password, I do get an unauthorized, right? And I didn't have to change anything about, fetching the credentials in the request. So if you're making an authorization decision, it's good to make it inside an authentication provider. And you get a lot of other free stuff. You get observability from it. You get events. So for example, we could create a bean that listens to events. That's an application listener of, say, authentication success events. Success event listener, right? This is a thing that takes an event. And so what are we going to do? We are going to write to the console. So like this, tada, logged in as %s. And we inject the values here. So the event has an authentication, which has a name. And the event also has, and the authentication has a class, and we can show the name of the class, right? So if I run this again and pull this up, try and do a successful authentication here, or if I try and go to the page and log in with auth, right, private. So it tells me in the console, Daniel logged in as username password authentication, user 112503, and so on, logged in as an auth2 authentication token. So I can, broadcast this event, log stuff. However, our robot filter that we implemented as a filter here, beep boop, sorry, it doesn't use the authentication provider abstraction in the authentication manager, so I don't get the events for free. We're not going to refactor the filter to actually use this, but in the code repo that I will provide the link to at the end, you can see further refactorings to actually show the how to use an authentication provider in a custom filter. So how to finish this correctly. Okay, so TLDR, authentication, bag of credentials, or successful authentication. And you make these decisions in authentication providers. And so you make your rules, you create them in authentication providers rather than filters directly. Right. So to wrap this up, the last thing, now that we know the three building blocks, the filters, the authentications, the authentication providers, how does that help us understand Spring Security? Well, glad you asked. In the security filter chain, when I call any of these, like form login, HTTP basic, authorize HTTP request, what this does is that actually creates here in the HTTP basic case an HTTP basic configurer. And if you look at the Java doc of the HTTP basic configurer, it tells you it creates a filter of type basic authentication filter. And so if you want to see how it works and how you can extend it, you see that it's going to go through that filter. Same, if we go for OAuth2 login, we get an OAuth2 login configurer, and we could look for authentication provider here. It's not in the Java doc, but we know how authentication provider work, and so we see how Spring Security creates those for us, and so we can understand, oh, it performs login using this provider and that provider. You still have to understand OAuth2 to extend those, but at least you know where to start. All right, we're at the end, so TLDR, I hope you're still awake. Remember, filter for performing security decisions, authentication providers to do actual custom login. To see how this is actually implemented in a protocol you use, you go through the configurers in the filter chain. For custom login, please do a filter with a custom authentication provider. Do not perform authentication in your controllers. The controller is not meant to check the password. The controller should never see the password, right? Authentication should happen inside the filter chain before the authorization filter. Controllers are made to return HTML pages and JSON responses and so on, right? So that's what you do in them. Even though Spring Security has filters that generate stuff for you, right? This login page is generated in a filter. You could do it for your end application. Don't do that. Just do it in the controller. That's the most obvious place. And with that, the resources of this talk, the slides, which is a repo, I'm going to rework it so that they're online. The code And in the code, I have the page here. I'll show that again. You have all the steps of the demo, and it explains all the things that we did and all the things that we should be doing. And if you look at the history of the commits, each commit adds one step of what we've done and what we would do if we had a little bit more time. And with that, I will leave you to rest. Please give me feedback live, on the app, on the internet, where you want, so I can improve, and come to me with all your questions. I'll be very happy to answer. I think that's about time. 16:10. Boom. Thank you.